Hey guys, my name is Trevor Sullivan and welcome back to my video channel. Thanks for joining me, and if you've learned something new or appreciated the creation of this video, please leave a like and a comment and also subscribe to this channel to help me grow this community and help to bring you a lot more videos similar to this one. Also, if you got something out of this or think somebody else will, then please feel free to share a link to this video or playlist or this channel with your friends, family, and your professional contacts. So what we're going to do in this video is continue our learning in this series about LXD for Linux. Specifically, we're going to be talking about storage volumes as they pertain to LXD virtual machines. We're also going to be learning about things like storage pools and some of the different drivers that are available. And once we get through some conceptual understanding about storage pools and volumes for Linux virtual machines, we'll actually jump into a live demonstration so that you can actually see how these concepts work in practice. And hopefully you'll be able to follow along on your own Linux environment and create your own LXD virtual machines, storage pools, and things of that nature. So for starters, let's talk about some of the different storage drivers that are available, because you'll need to know what different drivers are available when you are creating storage pools. Now, when you run LXD init, that's when you install LXD on your physical host for the first time, and you're getting ready to initialize the LXD environment so you can create virtual machines. The default storage driver that's going to be set up by LXD is the ZFS storage driver. However, there's also other storage drivers available depending on what kind of storage you prefer. For something that's really simple, you can actually just use an empty directory. So you can create a directory on some disk somewhere, and you can just point LXD over to that alternative directory to create your virtual machine disks on that separate physical disk. There's also support for Btrfs, LVM. I actually really love LVM. It gives you tons of flexibility over how you control your physical disks and pool them together and stripe or mirror data across those different disks. So it's really great to see that they have support for LVM. And then if you need support for remote storage, you can actually set up your own Ceph cluster. Ceph is kind of a separate topic on its own. It's a really huge topic because it allows you to get very complex setups for storage, but it has support for remote block devices, or RBD. You can also create remote file systems and then just mount those remote file systems directly into your VMs. And there's also support for Ceph object storage, which you can kind of think of like S3 object storage, where you can store basically arbitrary data blobs or files inside of that remote storage. But for simplicity, we're going to focus on the default, which is ZFS here, as well as directory-based storage as well. And then in the future videos, we might actually have a chance to look at some of these other storage drivers, depending on what the focus is. All right, so let's talk about storage pools. So as I mentioned, when you run LXD init, you're going to get this default storage pool with a name of default, and it's going to be using the ZFS driver. What that means is that when you run LXD init and then go on to actually create virtual machines themselves, it doesn't matter what operating system the virtual machine itself is running. It could be Ubuntu Linux, it could be Alpine Linux, it could be some other distribution. Those virtual machine data disks that are backing their root file systems, basically the operating system disk, is going to be created inside of that default ZFS storage pool. Now, you can also create additional storage pools as well using either ZFS or other drivers that you'd like to use. For example, let's say that we wanted to create a directory-based storage pool. So we can create one with a name like mydir01, just to give it a unique name, and then specify the dir storage driver for this storage pool. In order to create a storage pool with a particular driver, we use this command right down here called LXD Storage. That allows us to manage the storage pools on our LXD host. Then we specify the create subcommand because we want to create a new storage pool. Then we specify a custom name for the pool that we want to create. So in this case, mydir01. And then we specify the driver, which in this case would be dir, or you can refer to the table in the previous slide. Now, there are certain options that you can specify on each of these storage drivers. In the case of the dir storage driver, we can actually specify a source property that tells the storage engine where to specifically locate those files. You don't have to actually specify that, and there's a default storage path that LXD will use if you don't specify what that source property is. But if you do need to specify a particular location, then you can specify a source equals path at the end of the LXD storage create command. Now, once you create the storage pool, you can start to create virtual machines that have their backing rootfs disks on that new storage pool. So right here, we create maybe another Alpine Linux virtual machine on the same LXD host, right? We're just talking about a single LXD host at this point. So we have two other VMs using the default storage pool on the host, but now we create another Linux VM that has its rootfs disk located on this custom storage pool using a directory somewhere on the file system. In order to specify the storage pool that you want to use when you're launching a new virtual machine, all we need to do is specify -- storage equals, and then the name of the storage pool that we want to create the virtual machine's disk on. So in this case, we'd say LXD launch -- storage equals mydir01. LXD will say, okay, I can see that you've got a storage pool with that mydir01 name. It's of type directory. So I'm going to go over to the directory that that storage pool points to, create a virtual disk for this virtual machine, and then boot the virtual machine's operating system. So it's pretty simple to use here, not too complex, but we're going to take a look at actually how to do this in a little bit here. Next, let's talk about the default LXD virtual machine disk configuration. This right here is a screenshot or snapshot of the fdisk command running on the LXD host itself. So after we've created a virtual machine running maybe Ubuntu or Alpine Linux, what does the actual virtual disk configuration look like in the default storage pool? Well, for starters, if you look at the top left of the output here, you can see that the device here is actually a ZFS disk device, and it has a size of 10 gigabytes. So what that means is that when we create a new Linux virtual machine with LXD using the LXD CLI tool to run the launch command, the default disk size is going to be 10 gigabytes. Now, depending on what kind of workload, what kind of application it is that you're going to be running inside of these virtual machines, you might want to either increase that or potentially even shrink it if you just need a tiny virtual machine for a very specific purpose. So the second thing we want to pay attention to here is the size of the actual file system. So even though the disk itself has been provisioned with a size of 10 gigabytes, the boot partition is 100 megs right here. That's the EFI system partition. And then the root file system itself is only 3.9 gigabytes in size, so just shy of 4 gigabytes. So what that means is that the default configuration here includes a bunch of free space, and if we want to use that free space, we actually have to go into the virtual machine itself and expand the Linux root file system here from 4 gigs all the way up to whatever size that we want, up to the full size of the physical disk, or in this case, it's a virtual physical disk from the VM's perspective. All right, so next is how do I actually create a larger LXD root file system? So let's say that maybe we wanted to create a 25 gig rootfs instead of the 10 gigabyte default rootfs. Well, this is pretty easy to do, and if you take a look at the configuration of a virtual machine, you can actually expand the size property of the root file system right here by simply specifying the size property. So if you run lxcconfig show -- expanded and then specify the VM name, it'll actually print out the default configuration of the root block device here. And if you want to launch a virtual machine initially with a larger size, you can use this parameter in the orange right here, -- device root, comma, I know it's kind of a weird syntax here, but we say root, comma, size equals, and then specify the size of the root file system for that device. All right, so now let's talk about data disks. So we've been focusing on the root file system or the operating system disk for our virtual machines, but what if we needed to add extra storage on a separate data disk than the root file system where the operating system files reside? Well, we can do that with LXD, and we can actually hot plug, which basically means that we can add a data disk to a running virtual machine. We don't have to shut it down first in order to add extra storage to it. So if we wanted to add a second data disk to the same virtual machine, we could say, all right, I want a block device that's maybe 6 gigabytes in size. I'm going to put it into the same storage pool here, default, and that's got ZFS backing by default. So what we do is we say LXD storage volume. So now instead of going into storage, we go into storage volume context. And there's, again, a create subcommand in there. And then the default value for the type is actually going to be what's called a file system. But if you just want a raw block device, like a physical virtual disk device, then you specify -- type equals block. Then we specify the storage pool where we want to create the disk. So that would be default here. And then we specify a name for the new volume, and the size equals property can specify the size of that virtual block device. Now, once we've created the block device, it's only been created in the storage pool. It hasn't actually been attached to the virtual machine. So in order to attach the block device to a VM in LXD, we just use LXD storage volume and then attach, specify the pool that the data disk belongs to. So again, that would be default here. Specify the name that we gave to that custom data disk. And then finally, we specify the virtual machine's name that we want to attach it to. Also, there's an optional setting that you can add on at the end of this command to attach it, where you can specify the actual device name that will be exposed to the virtual machine, but that's not a required argument to the attach command here. Now, if you want to delete a block device, all you need to do is specify the storage pool, so in this case default, and the name of the volume that you want to delete. However, if you try to delete a data disk that's already attached to a running virtual machine, then you're going to get this error that says the storage volume is still in use. So what you'll need to do before you attempt to delete it is to actually detach it from the virtual machine using the detach command instead of attach. Also, keep in mind that virtual machine data disks can belong to a different storage pool than the operating system or rootfs file system. So if we had a second storage pool on our LXD host, we could actually take a data disk, provision it in that separate storage pool, and still be able to attach that to the virtual machine. So the rootfs and the additional data disks don't necessarily have to belong to the same default storage pool here. All right, so now that we understand some basics about storage volumes as far as the rootfs goes and additional data disks, let's talk about some things that you can practice yourself in order to learn about LXD. So first of all, you can create additional block storage volumes, additional data disks like we just talked about. You can attach additional data disks to your LXD virtual machine instances. You can also resize your rootfs. So if you want to expand your operating system disk size because you're using up your storage, then you can resize it, as we previously talked about. You can also create a custom storage pool using any of the supported drivers like directories, ZFS, LVM, and so on. And you can also deploy virtual machine instances using that custom storage pool as the backing storage mechanism for the rootfs file system. All right, so it's time for us to jump in and actually put things into practice. I would encourage you to follow this playlist right over here called Open Source Software, which you can find on my channel at youtube.com/TrevorSullivan. And this video will be added to this playlist. So what we're going to do now is actually jump into our LXD host. I've already created a LXD virtual host on top of my physical node here, and all I've done is installed snapd. I've installed LXD version 1.5.13, and I also installed btop so that we can monitor the system, and I'm using the Ubuntu 23.04 Lunar Lobster operating system as the host operating system for our LXD host. So if I run lexc list here, let me actually exit and re-enter my session. And if we run lexc list, you'll see I don't have anything in here, and I haven't even initialized LXD itself. So we're not even going to be able to use LXD at this point until we run through LXD init. And as part of this process, you're going to see that, do you want to configure a new storage pool? And we say the default is yes, because we have to have a storage pool so that LXD knows where to store virtual machine disks. The default name of the new storage pool is just default. The default backend is ZFS, as we can see right here, but we certainly could choose another if we wanted to. And then it'll ask us, since we chose ZFS, do we want to create a new ZFS storage pool? And we'll just say, yes, we do. Do we want to use an empty block device? Well, no. In this case, we're just going to use our operating system disk. And then what is the default size of the new device? So that's going to be the 5 gig size there. And so we'll just go ahead and use all of these defaults. But I did want to point out to you that during LXD init, it does create this default storage pool right here with this configuration. So once LXD has been initialized, if we do LXC storage list, you can see that we have our default storage pool using the ZFS driver. So at this point, we can go ahead and let's say launch a virtual machine. So we'll do LXC launch VM, and we'll specify an image. So we'll say images Alpine 3.18, and I'll just give it a name like A01. And it's actually going to fail to launch because I didn't specify the secure boot equals false option here, but it is going to download the image from the LXD image server and cache it onto the local file system. So now that the image for Alpine Linux has been cached locally, if we do a LXC list command, or actually let's do a storage list command here. Now what we want to do is actually take a look at the volumes that are on this default storage pool. So we'll say LXC storage volume list. And when you do a listing of volumes, you actually have to specify which storage pool you want to list the volumes for. So we'll just tack on default because that's the storage pool that we're trying to examine here. And in this table right here, you're going to see that we actually have an image volume, and we also have our virtual machine volume as well. So there's actually several different types of volumes that can be created. The custom volume is the type that you would see if you create a data disk, but you also have images that are used to launch virtual machines from, and then you also have the root file system of each virtual machine that you are creating here. So that's how we can inspect the volumes for each of our VMs on our LXD host. All right, so let's go ahead and fix our VM config. So I'll just do LXC config edit. And for our virtual machine here, A01, we're going to specify the security.secureboot equals false, false actually. We'll go ahead and exit out and we'll do LXC start A01, and that should allow us to launch our virtual machine. So now if we do LXC list, you can see that our VM is up and running. So let's go ahead and actually create a storage pool for starters, and then we'll add in a data disk on that new storage pool, and then we'll attach that new data disk to our Alpine Linux VM. So in order to create a new storage pool, we're going to say LXC storage, and then we want to use the create command here to create a new storage pool. So we'll do create help. And all we need to do is specify the name for the pool and the driver that we want to use. And we have the optional key value pairs here. And you can actually inspect the documentation for each of the storage drivers. So if we come over here to the LXD docs, go down to storage, take a look at storage drivers, and then take a look specifically at the directory driver right here, you can see that one of the configuration options available for the directory storage driver is the source right here, and that will provide a pointer to a specific directory where we want to store data for virtual machines created in this storage pool. So let's do a LXC storage create. We'll give it a name like Trevor Durr, and then we'll use dir as the driver name. And then we'll say source equals maybe /data/LXD data. Now that folder doesn't actually exist, so we need to go ahead and create it. So we'll say make dir -p /data/LXD data. And then we can go ahead and run our create command for the storage pool. So now if we do LXC storage list to list the storage pools, now you can see that we have our default ZFS storage pool, but we also have Trevor Durr, which is a of type dir using the dir storage driver, and it's in /data/LXD data, which is a custom directory that we created on our LXD host. So if we do an ls on /data/LXD data, you can see that we've got this entire folder structure that was created by LXD. And so if we create any virtual machines or any disks inside of this LXD host and put it into the Trevor dir storage pool, then all of that data is going to get stored under this folder structure here. So let's create a data disk inside of this storage pool that we just created, and then we'll attach it to the virtual machine. So we'll do LXC storage, and this time we want to work with volumes because we want to create a new volume. So we'll go into the volume context here, and we want to use the create command here to create a custom storage volume, also known as just kind of a plain data disk or block device. So if we do LXC storage volume create and look at the help for that, you can see that we can specify a pool and a volume. And we also need to specify the type of block because the default is the file system type, but in this case we just want a raw block device that we can format on the virtual machine itself. Now we can also specify the size of our volume. So let's say maybe we just want maybe a 1 gig volume. We can tack that on at the end right here when we create the volume. So let's do LXC storage volume create. We'll specify the Trevor dir storage pool, and I'll just call this data disk 01, and I'll specify the size property here of 1 gigabyte. And as you can see, we've now created this volume. So let's do LXC storage volume list on the Trevor dir storage pool, which is of type directory. And now you can see that we've got this brand new disk that's currently not being used by any virtual machines because, again, we haven't attached this to our virtual machine just yet, but the type of a custom data disk is going to just be custom. You can also get details about a specific disk by using the storage volume show command here. And then we can specify the pool and the volume name that we want to show details for. So our pool is Trevor dir, and our volume name is data disk 01. And as you can see under the config section, our size is 1 gigabyte. Awesome. So this is actually of type file system, so I totally forgot to do that. So let's actually just delete that really quick. We'll do LXC storage volume delete Trevor dir data disk 01, and then we'll rerun our command to create it, but we'll do -- type equals block. And now if we do our show command, now we can see it's block. I'm glad I caught myself before I tried to actually attach it. So now that we've got our data disk created, we can just do LXC storage volume. And this time we want to attach our custom data disk to a specific virtual machine so that we can use that block device on that VM environment. So what we do is run the attach command. So we'll say attach help. And as we saw in the presentation, all we need to do is specify the pool, volume, and instance or virtual machine name that we want to attach the device to. And again, we also have the ability to specify the device name that will be exposed inside of the virtual machine, but that's not a mandatory argument. So we'll do LXC storage, volume, attach, give our pool name, which is Trevor dir, and then we'll specify our data disk, which is data disk 01, and we want to attach that to the virtual machine called A01 because we don't have any other virtual machines, right? If I specify an invalid name, it's not going to allow me to mount it or attach it. So now we've attached the volume, and if we do a show on our data disk right here, now you can see under used by that it's currently being used, this data disk is being used by a particular virtual machine called A01. So now let's go into A01 and see what our storage volume looks like. So we'll do a LXC exec A01, and Alpine Linux has sh, not bash. So we'll do sh, and let's do apk add lsblk. This is a really common utility that's used to list block storage devices on a Linux host. So what we'll do is just run lsblk, and right down here you can see that dev SDB is our 1 gigabyte disk. However, it doesn't currently have any partitions on it. So what we can do is install another utility called CFdisk, and this is a graphical terminal-based application that allows us to configure our disks. So if we do CFdisk /dev/SDB, we have the ability to specify what type of partition table we want. Generally on EFI systems, we'll use GPT. And as you can see, we just have completely free space starting from sector 2048 all the way up to sector 2,097,118. And the size here is just under a gigabyte. So now what we can do is say, I want to specify a new partition. So we can use the left and right arrow keys to choose which option we want down here. So we'll say new, and we'll specify a partition size all the way up to the maximum. You can also specify the number of sectors. So if you wanted to, you could say 209 or 2,095,071 S for sectors, and that will chew up all of the sectors on the disk. And now we can go ahead and write that partition table, and we now have a partition called /dev/SDB1 instead of just free space. So it says, are you sure you want to write the partition table? We'll just say, yes, we are. And so now if we quit CFdisk and run lsblk again, now you can see that our block device /dev/SDB actually has a partition called /dev/SDB1. However, we have not yet formatted this file system. So let's do apk search for makefs here. And we want to install this package right here called e2fsprogs so that we can install makefs for ext4 file systems. So we'll do apk add e2fsprogs, and that'll install makefs.ext4. And so then all we need to do is say makefs.ext4 /dev/SDB1, and that will format our partition as an ext4 file system. So if we do lsblk again, you're not going to see the specific format here, but if we do lsblk, I think it's --all, there is one command that we can use here to actually specify that we want to see the partition types. If we do a help here, I'm not sure exactly which one it is here. I think it might be -f or something. Yeah, --fs, lsblk -fs. And so now under SDB1, you can see that it has a partition type of ext4. Awesome. So at this point, all we need to do to use that storage is to mount it to the virtual machine. So I'm going to create a mount directory under /mount/Trevor data, and we'll just do a mount /dev/SDB1 to mount Trevor data. And so now anything that we put into /mount/Trevor data is going to be stored on this partition on this separate disk. So if we just do ls/mount/Trevor data, right now there's nothing in there, but if we maybe just install vim here really quick and create a text file, we can very easily create data in that disk, and then it's going to be persisted into that separate data disk. So we could delete the virtual machine, but then mount that separate data disk to a new virtual machine and still be able to read the data off of it. So I'll just create a file here called test.txt, put my name in there, Trevor Sullivan, whoops, let's do Sullivan there, and write that file. And so now that file exists on our separate data disk, which has been mounted under /mount/Trevor data. So that's how we can create a separate storage pool, create a data disk, mount the data disk or attach the data disk to the VM, and then format or partition and then format the disk, mount the disk in the VM, and start writing data from our applications onto that disk. Now, the last thing that I wanted to cover here is how you can actually expand the root file system. So let's do lsblk right here. And as you can see, /dev/SDA is actually a 10 gigabyte disk. And we saw that during the presentation where we had the screenshot that shows the default configuration of a LXD virtual machine's disk. It's 10 gigs, but the root file system is only 3.9 gigabytes. So how do we resize or expand that root file system to take up the entire disk so that we can make use of that space? Well, once again, we're going to go back to CFdisk right here. And if we run CFdisk with no parameters, it's just going to by default use the OS disk here. And so what you can see is that we have the boot partition here, 100 megabytes in size. We have /dev/sda2, which is just about 4 gigs, and that's our root file system containing our operating system files. And then we have this free space down here. So what we can do is select our current root file system, which is /dev/sda2, and then we want to choose this resize option right here by using the left arrow key. And then we'll specify the new size. And by default, it's going to plug in the maximum here. So it's going to say 3.9 is the current size, plus 6, which is the current free space remaining, totals up to 9.9 gigabytes. So we'll just use that size. And just like that, we've expanded it. We'll go ahead and write the new partition table to the disk, and we'll quit CFdisk, rerun lsblk. And now you can see that our root file system right here is now been expanded from 3.9 gigabytes all the way up to 9.9 gigabytes. And you can also resize beyond that as well. So back on our LXD host here, we can actually edit the configuration of the disk that contains the root file system. So if we do lxc config show -- expanded for A01, you can see right down here that the root disk is currently using the default size, but we can actually expand that disk even further. So to expand the existing rootfs of a VM, we're going to use lxc config, and we have the ability to modify device configurations right here. So we'll say device context here. And then we want to override the default configuration of the root file system. And then we need to specify after override here which virtual machine we're affecting. So that's going to be A01. And then we want to specify the device name, which is the root file system. And then we can specify the size property. Let's say maybe we want to expand to something like from 10 to 12 gigabytes. So we'll do 12 GIB here. And now you can see that we've overridden the default configuration for it, and we've specified a custom size. So now if we show the configuration of our VM again, you can see that we now have the size property here for the root file system. And if we go back into the virtual machine by using the exec command right here and run lsblk, we should be able to see that this disk eventually expands. We may have to reboot first or do a disk rescan, but this disk has been expanded to a new size, and we can go through the CFdisk utility to once again expand the /dev/sda2 partition here to fill up the remainder of that free space that we just allocated to this virtual machine. So for now, I'm just going to go ahead and reboot it, and then we'll see if it's expanded after it comes back up. And as you can see, as soon as the VM comes back up, /dev/sda has been expanded to 12 gigs. And so we could go back into CFdisk once again. We see that there's more free space available in the green right there. So we'll just go to /dev/sda2 partition, say resize, just hit enter to take the default and write that partition table. And once again, we have expanded the size of the OS disk or rootfs of our Linux virtual machine running on LXD. So in any case, I hope you've learned something from this video. We learned about storage pools, storage pool drivers available in LXD. We talked about how to create data disks on custom storage pools, how to create virtual machines on custom storage pools as well, and how to dynamically expand the size of your operating system or data disks that are used in LXD. Again, please like this video, subscribe to the channel, leave a comment, and let me know what you thought of this video, and we'll see you in the next video. Take care.